11.2, Arithmetic Sequences and Series. Remember the difference between a sequence and a series. A sequence is just a list of numbers, or a series is a sum of a sequence. In this lesson, I want you to be able to do two things. I want you to be able to write the rules for arithmetic sequences and to be able to find the sums of arithmetic series. Let's begin with what is an arithmetic sequence. An arithmetic sequence is a sequence where there is a common difference, where the difference between consecutive terms is constant, and that constant difference is called the common difference. It is notated or denoted by the letter D in the formulas that we'll talk about in this section. First thing I want to talk about is how do you determine if a sequence is an arithmetic sequence. To determine if a sequence is an arithmetic sequence, you want to take the difference of the previous term. You always want to take the last term minus the previous term and find what that difference is. So here we would do 10 minus 6, you get 4. Remember, you always want to subtract the previous term, and the difference has to be constant. 6 minus 2, again you get 4. So far it looks like this would be an arithmetic sequence, but when we go one more time, we see when we do 2 minus 0 that that difference is only 2. This difference is not constant, so this is not an arithmetic sequence. Let's go to the next step. 29 minus 23, that difference is 6. 23 minus 17, again that difference is 6. 17 minus 11, again that difference is 6. 11 minus 5, that difference is 6. This sequence has a constant difference of 6, so it would be an arithmetic sequence where D is equal to 6. Now remember, when you're looking for that constant difference or that common difference, that you are always subtracting the previous term. Okay? Always subtract the previous term. Alright, let's move on to how we would write a rule for an arithmetic sequence. In an arithmetic sequence, the rule always follows a certain pattern. To write the rule for an arithmetic sequence, any term is always equal to the first term plus n minus 1, where n, remember, represents the number of term that you're on, times d, which is your common difference. So any term is found by taking the first term and adding n minus 1 times the common difference. Let's look at an example. Here in example 2, we want to write a rule for the nth term of a sequence. If this is an arithmetic sequence, remember, we would use the rule that any term is equal to the first term plus n minus 1 times that common difference. So the first thing that we want to see is there a common difference? So we subtract 77 minus 62, and we find that that difference is 15. 62 minus 47, again that difference is 15. 47 minus 32, that difference is 15. So we know that there is a common difference of 15. So now we can write the rule. Any term would be equal to the first term plus n minus 1 times the common difference of 15. Now you don't want to leave the rule like this. You want to simplify it. Use your distributive property. Put like terms together so that we have the rule any term would be equal to 17 plus 15 times n. The second part of this asked us to find the 12th term. To find the 12th term, put 12n for n, so you have 17 plus 15 times 12. Simplify, and you find the 12th term would be 197. Now, on the next slide will be a practice problem of this example. Pause the video after going to the next slide. Pause the video, give this problem a try. See, can you do it? I'm going to write the answer down after you've paused the video and try to work the problem. Check your answer. If you've not gotten the correct answer, maybe go back and watch the previous slide and try again. Alright, hopefully you've paused the video and now I've turned it back on. You were supposed to write a rule for any term. The rule for any term here should have been that any term would have been equal to 23 minus 6n. If you did not get this answer, maybe go back and watch the previous slide, watch that example again, and give it another try. Alright, let's move on to something different. In this example, they've given us one term of an arithmetic sequence. One term of this arithmetic sequence, or we should say the 8th term of this sequence, is 50. They've given us the common difference, 0.25, and they want us to write a rule for the nth term. Because they told us it was an arithmetic sequence, we know we can start with the rule that any term would be equal to the first term plus n minus 1 times that common difference. The problem is, we don't know the first term. All we know is that the 8th term is equal to 50 and that the common difference is 0.25. So we'll plug this information into our rule. We know that 50 is what the 8th term is. Well, that 50 could be gotten by taking our first term plus the number of term that we were on, which was the 8th term, minus 1, times the common difference, which is 0.25. Well, 8 minus 1 is 7, and then 7 times 0.25 would give us 7/4. So you would end up with 50 is equal to the first term plus 7/4. Subtract that 7/4 from both sides, you would end up with 48 1/4, or 48.25 is equal to your first term. Now that we know what the first term is, we can come back and we can write the rule for any term like they've asked us to. Let me change colors here. So now we can write the rule for any term. Any term then would be equal to that first term, 48.25, plus n minus 1 times the common difference of 0.25. Simplify 48.25 plus, distribute the 0.25, put like terms together, and we have our rule. Any term then is equal to 48 plus 0.25 n. Just like the previous example, on the next slide there is a practice problem. I'd like for you to pause the video after looking at the practice problem, try to work it, see how it comes out for you. So here we go. Here's a practice problem for you. Pause the video, give it a try. After pausing the video, check and see is your answer correct. If it's not correct, maybe go back and watch example 3 and give it another try. Alright, hopefully you've paused the video and you've tried to give the problem a try. If you worked it correctly, you should have found that any term here, would have been equal to 9 minus 6n. If this is not the answer that you got, maybe go back and watch example 3 again, give it another try. Okay, let's move on. Alright, in example 4, you've been given two terms of an arithmetic sequence. It's important that they told you that this was an arithmetic sequence. Because they told you it was an arithmetic sequence, you know that you will use the rule that any term is equal to the first term plus n minus 1 times the common difference. In this, they've asked us to do two things. Let's start with writing a rule for the nth term. To write a rule for the nth term, we're going to need to know what the first term is and what the common difference is. They haven't given us either one of those pieces of information. They've only given us what the 5th term is and what the 30th term is. To work this problem, what we'll do is write a linear system using the 5th term and the 30th term, solve for both the first term and the common difference. Then once we know what the first term and the common difference are, we can go back and write a rule for any term. To write a equation or linear system here, we know that the 5th term is equal to 10. So 10 would be equal to your first term, which you do not know, plus this n minus 1, where n is the number of term that you're on. So n would be 5. You would have 5 minus 1, or 4. So this would be plus 4d. Now we're going to do the same thing for the 30th term. We know that the 30th term is equal to 110. That also would be equal to your first term plus n minus 1. Well, since this is the 30th term, then n is 30. So you have 30 minus 1, or 29, times d. Now you have a system of linear equations. You have two equations in the same variable. Both equations have the first term is one variable and the common difference is another variable. If you remember back how to solve linear systems, there are several methods that can be used. One method is linear combinations. Linear combinations would be easy here. Remember, with linear combinations, you want one of the terms, one of your variables, to be exact opposites. It would be easy to make the first term exact opposites by multiplying everything in the first equation by -1, so that we'd have a -10, a negative first term, and a -4d. Add the two equations together, you would end up with 100 is equal to, the first terms would cancel out, 29 minus 4d, you would end up with 25d. Divide both sides by 25, and you find that the common difference is 4. So we have one of our missing variables. We just need to go back and find what the first term is. It would be easiest to go back to the first equation and substitute in d, so that we would have 10, change to a different color here. Alright, so substitute in 4 for the d, so you would have 10 is equal to the first term, plus 4 times the common difference, which is 4. Simplify. 4 times 4 would be 16, and subtract that from both sides. 10 minus 16, you would end up with a -6, then, is equal to your first term. Well, now we had the two missing pieces that we needed to write a rule for any term. Remember, a rule for any term is always equal to the first term, which we now know is -6, plus any term minus 1 times the common difference, and the common difference is 4. You would want to use your distributive property and simplify, so you would have -6 plus 4n minus 4. Put your like terms together and you find that any term is equal to 4n minus 10. Okay, so this is our answer for part A. Any term is equal to 4n minus 10. In part B asks us to find which term would equal a -2. So we want to know, when does any term equal a -2? So you put the -2 in for any term, and you want to know what number of term would give you this -2. Add 10 to both sides, so you have 8 is equal to 4n. Divide both sides by 4, and you find that n would be equal to 2. So it's the second term that would give you a value of -2. Okay? Just like in our previous examples, the next slide is a practice problem. Pause the video, try the practice problem. If you don't get the result, the correct answer, go back, try again, go back maybe and watch example 4, look at it again, see, can you pick up on what your mistake was. All right? So pause the video, give it a try. All right, hopefully you've paused the video and you've given it a try. You were supposed to should have found what the rule was for any term. The rule for any term should have been negative 7.5 plus 2.5n. This should have been the rule that you came out with for any term. And then the final answer, which term would give you a 50? You should have found that it was the 23rd term. The 23rd term would be 50. Okay? All right, let's move on to series. An arithmetic series, remember, is a summation of a sequence. In an arithmetic series, you can find the sum of any number of terms by multiplying the number of terms times the average of the first and last term. So you need the first term, the last term. You would add those together, divide by 2, multiply that times the number of terms that you are adding. Let's give it a try. Okay, here in example 5, the first thing we want to do is find the sum of the first 25 terms. Since in the directions they have told us that this is an arithmetic series, we know that we need to use the summation rule, that the sum of any number of terms would be equal to the number of terms times the average of the first and last term. Well, what we want is the sum of the first 25 terms. So that would be equal to 25 times the average of the first term. Well, the first term here is 20. Plus, we want the last term. The last term would be the 25th term. To find what that 25th term is, we first need to know what the rule for any number of terms is. So we'll begin with the rule for any number of terms. We first need to know what is our common difference. So we look at our sequence, or look at the series here, find our common difference. Remember, you're always wanting to subtract the previous term. So 14 minus the previous term, 14 minus 6 would be a negative 2. Check it again, 16 minus 18, negative 2. So you know your common difference is negative 2. So any term would be equal to the first term plus n minus 1 times that common difference of negative 2. Simplify, then any term would be equal to, we're going to have negative 2 times a negative 1 is going to give you a positive 2, and you're going to multiply that, add that to 20. 20 plus 2 would give us 22, then multiply the negative 2 times the n also, so you would have a negative 2n. So this would be the rule for any term. Well, we're needing the 25th term. So to get the 25th term, put 25 in. So it'd be 22 minus 2 times 25. And you find that the 25th term then would be equal to 22 minus 50, or a negative 28. So negative 28 is what we need to put right here for that last term. So now we have the first term and the last term. We need the average of that first and last term. So 20 plus negative 28 would be a negative 8. Divide that by 2, you would end up with negative 4. And then 25 times negative 4, or a negative 100. That would be the sum of the first 25 terms. Okay, so again, we used our rule. To find the sum of the first 25 terms, we needed the number of terms, which was 25, times the average of the first and last term. We had to find what our last term was. We had to find what the 25th term was. So we first found what was a rule for any term. Then once we knew what the rule was, We could find what the 25th term was and plug that into our formula. Okay? Now let's go over to example B. And in B, we want to find which term, that's what the N stands for, which term would give us the sum of negative 760. So the sum is negative 760. Remember, the sum is equal to the average of the number of terms. It's the number of terms times the average of the first and last term. We know the first term, 20. But because we don't know what the last term is, we don't know if this is 25 terms, 26 terms, we don't know. Okay? So what we have to do is put in our rule for any term. We know that any term is equal to 22 minus 2n. So for our last term here, we would put in the 22 minus 2n. Now we need to simplify. The first thing you need to do is get rid of the divide by 2. So multiply both sides by 2. When you multiply both sides times 2, you're going to end up with a negative 1,520 is equal to n times. You can go ahead and add the 20 and 22. You could drop it off the parentheses around the 22 minus 2n and add the 20 plus the 22. End up with 42 minus 2n. You need to distribute the n. Okay. So we're going to have a negative 1,520 is equal to 42. Let's make that a little clearer. 42n minus 2n squared. Well, we see we have here a quadratic equation, so let's put it in standard form. 2n squared minus 42n minus 1,520 would be equal to 0. Every term is even, so let's factor out the 2. We have n squared minus 21n minus 760 is equal to 0. Now we would need to factor. You would want to use AC factoring. Don't want to review right now AC factoring, but if you don't remember how to AC factor, you can talk to me in class. I'll help review that with you. This trinomial is going to factor into two binomials. I'm just going to go ahead and give you the answer. This would factor into n plus 19 times n minus 40. Use your zero product property. You find that n is going to either be equal to a negative 19 or a positive 40. Now remember, we're looking for the number of terms. You can't have a negative 19 terms, so we know that's not the correct answer. So the number of terms that we would have to add together to get a negative 760 as the sum would be 40 terms. If we added 40 terms together, we would end up with a negative 760. All right. This next two slides are for you to practice. So give this one a try. If you're not able to get the correct answer, maybe go back and watch the previous example again. Watch example 5 a second time, maybe walk your way through it one more time. After solving this, you should have found that your 18th term, which is what they asked you for, the sum of 18 terms, the sum of 18 terms would have been 3,330. If this is not the sum that you got, go back, watch the video again, give it another try. Okay. The next slide is also another practice problem. Okay. Here's another practice problem, similar to example 5. Okay. Pause the video, give it a try. After solving this problem, you were looking for the number of terms that you would need to add together to get 600. You should have gotten two answers, a negative 24 and a positive 5. Because we're looking for the number of terms, the number of terms cannot be a negative number, so we know it had to be 5 terms. The sum of 5 terms in this series would give you 600. Alright, and that is the end of this video. Hopefully this was helpful to you, especially if you've been absent from class.